You may begin.
All right. Good morning, grade 11s, or good afternoon, shall I say, grade 11s. It's Information Technology, grade 11. My name is Mr. Freeman, and I've taken over from Mr. Nike. And hopefully, I will be able to teach you one or two things, and we can learn all together. So the topic of today is parallel arrays. Now, as I understand, Mr. Nike covered most of the array sections for grade 11. There's just this parallel arrays topic that remains, and we're going to dive right into it. So by the time we're done here, and if this was successful, I would like you to understand four things. Firstly, so what are parallel arrays? Okay, and if you understand that part, we're going to move into why we use parallel arrays. Why does it work for us? What are the uses? And after we've covered that part, we're going to look at two more things. And the first one would be sorting these parallel arrays and searching parallel arrays. Now you've covered sorting and searching already in your single arrays. We are going to expand this when we use parallel arrays as well. Okay, so what are parallel arrays? Well, if we look at those slides there, it says that it's more than one array of the same size where the same elements of the different arrays are related to each other. Now that is a mouthful. That is high English. Let's read it again, and then I'll try and break it up to you. So it says that it's more than one array, so it's multiple arrays. It could be two arrays, it could be three arrays. Okay. They're different arrays. They are exactly the same size. So if the one array's element is 20, then the second one would be 20, and the third one would be 20 as well. And the third part is that they are related to each other. So element 3 of the one array is somehow related to element 3 of the second array, and so on. So related, what does that mean? Well, they describe different attributes or functions of the same object. Now, these are probably big words. These are words that you would be more familiar with when you get to grade 12, but I want to start introducing these little terms to you already. Now, an object, that is something that you can, I suppose, see, and the example that we would be using would be a student. Now, a student may have some attributes or functions related to that student. In other words, something that you could identify the student with. And one obvious thing would be the name of the student, maybe the grade of the student, the gender, and so on. And if you take all those attributes together and combine them, those attributes will hopefully describe one student or one object. Right. So why do we use parallel arrays? Well, let's think about this class of student names and their marks. So I'm a teacher, I've got some student names, and they've written a test, and now I've got marks for them. So the question is, can we store or work with both the names and the marks in an array? Now you would have learned that yes, I could have student names in an array of type string, or I could have marks in an array of type int. But what if I need both of them? I need to work with or store both of them at the same time. Now, we know that arrays can only store elements of the same data type. So the names array would be string type, and the marks array could be integer or real type, because that would be the mark out of 20 or maybe a percentage out of 100. Now, there's already a problem there. So the one is a string, the other one's an integer. But we know that an array can only store one type of element. I may have a problem here. Let me just restart this. Okay, I see I'm still sharing. Just give me a second here so I can get back. Looks like we've got a drop in internet connectivity. Just going to try and copy this again. All right, so hopefully we are back now. Paul, is everything still okay? Can I carry on?
Yes, all is well. I just need you to share your screen.
Okie dokes.
Oh.
All right, sorry about that. I'm back. Looks like the internet dropped there for a second. I'm going to start at this slide again. So, what are parallel arrays? We said it's more than one array of the same size, and each one would be part of this big object, each one describing an attribute. And then we said, why do we use parallel arrays? Well, we're going to think about a class with students and their marks. Can we store both? We spoke about that arrays can only store elements of the same data type, so there's already a problem if we want to store names and marks in an array. Okay, I think this is about where I lost you there for a minute or two. So let's consider this example over here. So I'm going to store names and marks, and I'm trying to store them in the same array. So I guess the question is, can we do it this way? Well, let's look at this example over here. So I've made an array called R names and marks. It's size 6, so I've got 6 students in my class. And the first part of my element is the name, and then I've chosen a delimiting character. In this case, I've chosen colon. Because no name and no mark would have colon in there, but you can use any one you want. And then that's followed by the actual mark. So this could be one option to try and store both the name and the mark in the same array. But what are the difficulties surrounding this example? You know, practically, would this work? So I guess the first question I want to ask you is, what would you say this type of array would be? Remember, we can only have one type in an array. I guess hopefully you all got that answer, and that would have to be a string, because part of what's in this array element over here is a name or letters. So we have to make it string. So yes, I suppose I could do that. I could get my data from some input boxes. I could get it from text files. Text files is something that you'll be learning about in the near future. And later on, I could possibly get all this data from a database, which you will learn even later in the 4th term. So let's say I read in all my names and my marks, and I'm now storing them in this capacity over here. So now I want to maybe ask a question. I want to know what is the name of the person who got full marks for this test. Now you should be able to see that Chris is the one who got 100% for it. How are we going to answer that in terms of Delphi? So if I say, who achieved 100%, please return that name. Now you're going to have to loop. Now you've done searching. You're going to have to loop through this array and each case ask who scored 100. But how do I get 100 out of there? Because it's not 100. It says 4, the element at position 4, index 4, is Chris colon 100. So for each element, I would have to extract whatever's in there. And then I have to extract the different sections of the string. So I first have to go and get John as a substring. How would I do that? Well, I would suppose I would start at the beginning and go all the way until the character just before my colon. I could do that using my pos function. And then after that, I would have to also extract the 56. Now, I can't just take the last two because what if you scored 100? That's 3. What if you scored 7? That's 1 digit. So again, I would have to find the colon and get the rest of the string after the colon. And the key word here is it's a string. So after that, I would have to convert my string, which is 56, into an integer. So there's a lot of string manipulation if I try and do this model over here. It's difficult, it's messy, and there's a much better way of doing this. So let's go to the next slide. What if I don't use one array? What if I say, okay, no, I'm going to use 2 arrays, one for names and one for marks.
Sorry, Henry.
Okay, so what did we say in the beginning? What are parallel arrays? We said, number 1, they have the same size. So over here, I've got 1 to 6, and in my array marks, I've got 1 to 6 as well. Each one is storing their own data set of a specific type. So there's the names, and here are the marks. So that would be string, and this over here would be integer or real. So already can you see that it is not as messy as the previous example that we had over here. If I needed to sort, I could sort on either one, and I would just be able to use my normal sorting algorithm that you've done last week, and I could apply it to any one of the two. If I want to find, I can just search for Peter or Chris or Sarah, as is from my input box, loop through my array names, and I have my index position of 5. So that is already a lot easier. So,
Henry?
Yes.
Sorry, Spudara would like to know, could you put the array for the marks in a for loop? Not sure.
Could I put the arrays in the mark? Yes, absolutely. And that is one of the reasons why we use arrays. Now, if I had 6 students in my class and I had 6 marks for those 6 students, and the whole concepts of arrays never existed. So let's say programming, Delphi, whoever did not have arrays. How would I have to store these names? How would I store these marks? Well, there's only one way you could do that, and that is you would have to have your input box, and you would say, name the first student, okay, and then after the person typed in John, you would then have to ask, okay, type in the mark for the first student. And then you have to carry on and repeat this entire process. But when I say repeat, you can't loop, because how are you going to loop? How are you? Because John would be stored in S student name 1. And Mary would have to go into S student name 2, and Peter in S student name 3. So I would end up having 6 separate variables for my names and 6 separate variables for my marks. And then whatever new student joins the class, oh my word, the whole class is a mess again. So now I've got to make more. Now the whole idea with arrays is arrays with input, whether it's from keyboard, text file, or database, makes it possible for us to loop with a for loop. So if I know the name, if I know the size of the array, I can loop. In other words, in my loop, I would have an input box asking for the name and one for the marks. And I will show you how this is done. It's not entirely in preparation of this lesson, because I assume you would have covered that in previous lessons in arrays, but I will try and answer that question as we go along. All right. So, how do we sort arrays, or parallel arrays, that is, because I'm hoping that you by now know how to sort a normal array. It's a basic algorithm, and I'll explain it again as we get there. How do we sort parallel arrays? Well, exactly the same way we sort single arrays, except for a couple of extras. Now, if you wanted to sort a normal array, you would say, I would only have names, no marks. Think about that. So now I want to sort my names alphabetically. You would basically follow the algorithm that you would have learned about the outer loop and the inner loop and the if statement. And if that if statement was met, then you swap your elements around. And by the time we're done with this outer loop and inner loop, I would have an array of sorted names. Now I need to sort the parallel array. So my question now would be, okay, what am I sorting? Am I sorting names alphabetically? Am I sorting the marks from highest to lowest? Which one is it? Well, you would have to decide. Maybe you have a button and a checkbox that says how you want to sort this. So you have to choose in your code which array of the two you are going to sort on. Is it names or is it marks? Now, if you've decided that, or when you've decided that, inside the sorting nested loop, you've got to use that chosen array in my if statement comparison. And then once you've done that, if the condition is met, you have to swap the elements in both arrays. And that's another thing that comes in, because you have to keep a tab on both arrays. No use in sorting R names, but you forget about R marks. If I only sort R names, now which one's going to be first? That's going to be Chris, say, element number 4. If I only sort this one, Chris is going to end up with no longer 100%. He's going to now end up with 56%. So whatever we swap in our sorting algorithm, we have to do exactly the same in our second algorithm. So how do we do that? Let's look at the code. So here's a typical example of we having two arrays, one for names, one for marks. And this one is where we decide to sort the marks from highest to lowest. Okay, so hopefully you will recall this part over here. This is our outer loop for I1 to length of array marks minus 1. So that function over here, length, basically looks at the parameter that I'm passing, R marks, and it finds and it returns the length of this array. Now, in our case, it would be 6. I have 6 elements in R marks. Okay, so I'll currently be looping from I1 to 6 minus 1. Mr. Knight would have taught you why there's a minus 1 over there in the outer loop. And then my inner loop, I go for j, starting at I plus 1, all the way to 6. So my first name, which would be I, would be John, and J would be 2, which is Mary. And then after that comparison, if John is after Mary, it would then swap it. Actually, I should actually go to the marks, because this is what we're doing. We're sorting from marks over here. So I would be position 1, which would be 56. J would be position 2, which would be 78. I do my if statement. If required, I swap them around, and then J becomes 3. And I do the whole thing with 1 and 3. And after that, J becomes 4. I is still 1, because I is the outer loop. So I compare 1 and 4, 1 and 5, and 1 and 6 until I've compared all of the elements. So between my swappings and my non-swappings, by the time I've finished my first inner loop, what would I be guaranteed of having stored in position 1? I only know one thing, and I know that 1 will now have 100 because I found the highest value. Then, after that, I becomes 2. J now starts off at I plus 1, which is 3. And we start the whole process again. So I know now from my first output loop, I had 100 over here. And now I start again. And I start comparing I with J, I with J, I with J, and I with J. And after the second time, I now know I would have 100 still in position 1. And what will I now have in position 2? 91. Okay, so hopefully you understand that part. So to come back to my length function. Now, length function, for those who may or may not have heard about it, some functions are what we call overloaded. In other words, a function could sometimes do different sets of work depending on what I pass as a parameter to it. Now, I know about 2 examples of the length function. The length function can either take an entire array, in this case R marks, and it would return the number of elements in the array, or I could apply the length function on a string. Anybody can tell me what the answer would be if I apply a string with the length function, and let's say the string is sort. It's going to return 1, 2, 3, 4, the number of characters in the string. So this is an example of an overloaded method. Another example, those of you who may have done the pos function. In other words, the function that looks at a string and it says, okay, wherever you find, let's go back to here, wherever you find a colon, return its position. 1, 2, 3, 4, 5. So if I'm looking for a colon, it's going to return the position of 5. And if I want to then get 56 out of there, I would use a different function. I think it's called the substring function in Delphi. But that function could either return everything from the colon, or from the colon, how many characters am I going to carry on? So that would be an example of an overloaded method over there. Okay, I don't want to be too far off over here. So I've got my outer loop, I've got my inner loop, and inside there, for every single array, I'm going to ask my question. And I'm saying, if R marks at I is less than R marks at J. In other words, if the element on the left-hand side is less than the element on the right-hand side, then that is wrong. I don't want that. I want the highest elements on the left and move my way on. So if I is less than J, then it's wrong, then I've got to swap them around. So here's my swapping part, okay? I need to bring in my itemp if I want to swap. Because programming is not as simple as your normal human beings. If I gave you a banana in your left hand and an apple in your right hand, and I asked you swap the banana and the apple around, you would probably take your hands together, they would meet, and you would swap your fruit around that way. But computers don't work like that. If you were a computer and I asked you swap the apple and the banana around, you would have to first put down the apple on the counter. Now that counter is itemp. Then, with the hand that you've left the apple, you reach out to the other hand. You grab the banana. Now the banana is swapped, but your apple is still on the table. So the hand that just gave away the banana must now go and get the apple, and there it is swapped. And that's why we do this. So firstly, I take my element that is an R marks at position I, and I put it in itemp. Now I can overwrite R marks at I with whatever was in J. And once that is done, I can then take whatever was in I temp and place it in J. And then we repeat this for the other array. So this was for R marks. I temp would have been an integer variable. I've got to do exactly the same for R names. To a temp string variable, placing that in there for now. Now I can place whatever was at R names J into R names at I, and then lastly take whatever's in S temp and put it in R names, and my swap is complete. And this is the important part. Whatever you do for marks, you have to do for names. Otherwise, your names are going to be sorted, but your marks wouldn't have moved with them. And that's it for sorting parallel arrays. Let's look at one example. This example is I wanted to do it from highest to lowest. Here is what we would do if I wanted to go alphabetically according to names rather. Again, I'm looping through R length. I'm calling R names.length over there. Is there a question? Okay, I'll carry on. If I go back to R marks, I went length R marks, but it doesn't really make a difference. Why? Because they are the same in length. But anyway, let's just use R names because it makes logical sense. So there's R names, my outer loop, my inner loop. My question is now where I had a question of R marks less than R marks at J, R marks I less than R marks at J. I'm now saying if R names at I is greater than R names at J. Now it's the other way around because I want it alphabetically. Because R names at I, what do I reference when I say R names at I? I am referencing a string that is stored in R names at position I. And right at the beginning, it's at position 1. So that would be whoever the person was right in the beginning, which is John. Okay? So that is referencing a string that is referencing the next string, and I'm making a comparison. What am I comparing? John, I am comparing with Mary. Okay, so John with Mary. Is John greater than Mary? Well, how does Delphi do this? Delphi looks at the J from the John and the M of Mary. And every single character is represented by an integer as well. Now, I think capital A is somewhere around the value of 64, 65. But let's say it's 65. So if A is 65, then B would be 66, C would be 67, and so on. So B is a higher value than A. So I want to go alphabetically. So if I say R names at I is greater than R names at J, then that's wrong. I don't want that. I want it to be A and B, not B and A. And if it is B and A, or in this case M and J, if it is that way, we want to swap it around. Now with John and Mary, it's not going to happen because John is before Mary. But if it was the other way around, you would have to now and go into this if statement and do your swapping. All right, so there's my array name swapping, and here's my array mark swapping to go with it. I really hope this all makes sense to everybody. Okay, then lastly, after we've sorted parallel arrays, how do we go about searching parallel arrays? In other words, I want to know how many marks Mary got, or I want to know who scored the lowest. What is the name of the lowest? So again, exactly the same way, we search through single arrays with the following bits of extras. Okay, so now, because we're dealing with more than one array, we want to identify which array contains the elements that you are searching for. Am I searching for Mary or John? Then it's names. That's the first thing. Okay, so this becomes your condition that we'll look at right now. Secondly, identify which of the parallel array contains the element that must be returned. Now, in our example is, I want to know how much marks Mary achieved. So that will be the marks array. That is what I want to display or return once I found my match, which is Mary. Okay, so let's look at the code. I've got a few variables here to start off with. Now, you should find this familiar because you have covered searching arrays, but I'll go through it again. So my first one over here, we call it I. We start with 1. What is this? This is my array counter because I want to search for a specific element in the array, I don't know how many times I'm going to loop. Mary may be the first person. She may be somewhere in the middle. She may be right at the end. So this is not your typical for loop. I want to have a while loop. I want to say, while I haven't found Mary, and while I am still searching inside my array, because remember, we don't want to go beyond the size of the array. If my array is only 6, I need to stop at 6 if I haven't found Mary. So this is the one that I'm going to use in my while loop where I say, while I is less than 6, my length of my R names. I start off with 1 because I'm going to start off at the position 1, which is job. Okay, so that's why I have I equals 1 in the beginning. Then I have an I pos equal to 0, and my array is going from elements 1 to 6. So I start off by giving pos a ridiculous value that's not in the array, and we start off by giving it 0. And this pos is going to store the position of the element if it's found. It's going to start off at 0, and at some point it's hopefully going to find the element that I'm looking for, and only then will it change from 0 to whatever that position was. And then this over here is just a flag. The only reason I use this B flag over here is if I have found Mary after the second iteration of the loop, why should I keep on searching for her for the rest of the array? And that's what this B flag equals false is going to do. It's going to remain false until I find what I'm looking for, and then it becomes true. And I'm going to use that to exit my loop. Okay, so firstly, I'm going to ask. Okay, I'm going to say, okay, in an input box, I'm going to say, enter the name of the person you're looking for. All right, so the person's going to enter, let's call it Mary. That's going to be stored in my S search. And here's the start of my while loop. I'm going to say, okay, while I, which is currently 1, is less than length of R names. So I'm going to loop through the entire array, and B flag equals false. I'm only going to loop through the entire array while B flag is false. The moment I find this person, it turns true, then I want to exit this while loop. Right, so what's the first step? Okay, so I'm asking a question. I'm saying, if the first element in array names is the same as whatever this person typed in search, then what? Okay, I understand. Yeah, you probably could have done a little bit better here, because what if it's an uppercase in my array and not an uppercase over there? So you could probably have used the uppercase function in both cases for a bit of defensive programming. But either way, let's assume that everything is in lowercase. So we're saying, if my first element is the same of the person that I've searched, then what? In plain English, fantastic, I found the person, make my flag true, the position of the person that I found is 1. So I'm making IPOS whatever I was at that point. Fantastic, my searching is concluded, and end that part. So this is what I would execute if I found my person. See, there's the begin, there's the end. This inc I over here happens inside my while loop, but outside of this if. This will happen every single time in any case. I'll talk about that in a second. So if I found this person, fantastic. I've got pos as 1, I've got flag as true. So next time I'm going to go into my while loop, I is now 2, so that's still going to be true. 2 is less than 6, but B flag is no longer false, it's true, so I exit the while loop. And then I have one of two examples. If B flag is true, then, well, I found the person, and the marks for that person is the marks at I pos, the exact same position where I found Mary in the one array of R names. I'm now going to return for the mark that she got from the array marks over here. Else, well, what is else? Now this over here, B flag equals true. This is outside of my while loop. So two scenarios could have occurred here in my while loop. One, I could have found the name, or two, I never found Mary. Mary was never in my array to begin with. So what's going to be the difference? If Mary was found, I'm going to have a B flag equals true, and I'm going to have an I pos with some sort of value more than 0. If she was never found, then B flag would still be false right at the end. And what would the value of I pos still be? 0. It would never have changed. So after this, I could say either if B flag equals true, then she was found, this is her mark. Or you could have gone and said, well, if I pos is greater than 0, it would have been exactly the same thing. So if it is still false and still 0, this is where my else comes in. And this is where I then say, sorry, whoever you were searching for in search was not found. So exactly the same way, except for my if statement is based on one array, R names in this case, but what I'm returning is the same position, but from a different array. Okay? So what I would like you to know from this lesson is parallel arrays are useful when we have to work with multiple attributes. Now, we've spoken about attributes. Those would be like name or mark, or we could even go as far as grade or register class. Those are little attributes, okay? And that's when I'm working on multiple attributes of a given object, and the example that we've used today as an object is a student. We can do everything with them. We can sort them. We can search parallel arrays in much the same ways as we do with single arrays. Now, I know today's lesson, my starting lesson, was really a lot of theory behind parallel arrays. What I'm going to do, we're going to have one more lesson tomorrow on parallel arrays, and then we'll probably just finish off with arrays completely and go on to the next section, which is probably going to be text files. But for tomorrow, I'm going to use an example from those brand new DBE practical textbooks that you can get for free. They're excellent textbooks. I'm going to use a paper-based activity on page 67. And I'm going to convert that into a real Delphi program. And what we're going to do is we're going to look at an example of political parties going for national vote. So I'm going to have a few parallel arrays tomorrow. The one's going to store my candidates. So there's my digital party and the data party and so on. The one array is going to be storing the number of votes each party received. And then there's going to be an empty array that we are going to fill out through a loop. We're going to determine how many seats each digital party so each party, sorry, will have in a 400-seat parliament based on the number of votes that they've achieved. So there's going to be a bit of math in there. It's going to be quite interesting. We're going to be working with more than two arrays. So I'm always in a lesson like this, you're always afraid that people think, okay, so parallel arrays are always only two. No, not necessarily. It could be two, it could be three, it could be four. I suppose eventually it gets a little bit much to handle, but it doesn't have to be two only. All right, so so we're going to determine the number of seats in Parliament a political party will win based on the number of votes that they've achieved in their votes. So I'm looking forward to this. I'm excited, and I'm hoping that you'll be joining me tomorrow again. I'll show you a bit of Delphi code in doing this in our RAD studio. Thank you very much.
Thank you so much, Henry.
Thanks, A.